Hello, welcome back. We're talking about Kafka today, and with no further delay.
Yeah.
Hi here. We're talking Kafka, and with no further delay, António Ramadas was kind enough to lend a hand. So António, you take the first part, and then we move to something slightly more. Well, let's see how that goes. Totally yours.
So you should be able to see the screen now. First of all, thank you, Dima, for having me. Oh, sorry, yeah, a bit of spoiler. So I'm going to talk about my experience with Kafka and mostly focus on the strength. Afterwards, Dima will focus on everything else because what I will discuss won't be the only decisions that you probably will face when choosing Kafka or while using Kafka. Anyway, as Dima said, we'll see how that goes. I'm going to assume some familiarity with Kafka. At least you probably, it helps if you already know what topics are, what partitions are, and what Kafka is for. So with no further delay, were reasons to choose Kafka, at least the reasons I can come up from what I've experienced or what I've seen, read, and so on. Kafka has been here for a while, and it's been widely used by the industry, and that helps establishing its maturity. And because of that, there's a lot of great technologies built on top of that, and even companies like Confluent that start with Kafka and build their product on top of it. And because Kafka has been here for so long, and Kafka has been so widely used, there's a strong community built around it. That I traced down some reasons to it: documentation, books. Kafka documentation, the official one, the one on their website, is great. It helps you understand what Kafka is from a high level to a low level, and whenever you face an issue, besides you can check the documentation, the books, and if you look up the issue that you're facing, to search on the web, you mostly likely will find somebody else that faced that issue, questioned, and got answered, and probably that answer will lead you at least for the right path. Anyway, Kafka, just because everyone, well, not everyone, but most people, most companies use it, or most systems we use it, doesn't mean that we should use Kafka. Software Mill, I'm not affiliated with any of the companies that I'm going to mention, okay? So no endorsement or whatsoever. Anyway, what I found online is that Software Mill published an implementation checklist, which can help you at least make some decisions if you choose Kafka, and if Kafka is the best technology available for your use case. So moving on, Kafka has a strong focus on availability and scalability. You can go, those concepts are mostly related to in-sync replicas. So you have a leader and a bunch of followers. You write to the leader, and the leader will replicate to the followers. That helps guarantee availability. And regarding scalability, you can just have multiple consumers consuming from the same topic. One interesting property from Kafka is message ordering, but that only is guaranteed inside the same partition. So if you have a slow consumer and you have a fast consumer, you can be sure that inside the same partition, the slow consumer will consume the messages in the same order as they are published and as they were read by the faster consumer. That can help with causality ordering. If on the publisher, if in your system, that is important, and that is an interesting property. Kafka stores its messages on disk, which it's great for durability, and that helps strengthen the ability to replay messages. If you have a large enough disk, you can just consume since the beginning, and replay the messages with all the interactions, with all the updates that there has been until now. Because if you keep on publishing messages, you can establish policies based on time and based on size. And it's also great to have compaction, which guarantees that Kafka will aim to store the last update for each message key. So if you're consuming from the beginning and you can discard the intermediate states with compaction, you can just have the last state. Okay, so these were a few reasons. Your mileage may vary. You may come up with other reasons. One thing to note and one thing to acknowledge is that Kafka is complex, but ideas are simple. These are images I found online. I believe this presentation will be available afterwards on the description, and on the speaker notes, you'll find the links to this image. So none of this image is mine. So there are the reference, the speaker notes. Anyway, these images convey a lot of ideas here, and it can be daunting to try to understand everything that is going on. But if you separate the ideas, you'll see that the ideas make sense, obviously, and they are kind of simple. Kafka is complex because it's a group of a bunch of simple ideas. And I believe that is why Kafka can be perceived to be complex, but I think that shouldn't stop you from at least checking out Kafka. Now, one thing when I start is to see how others are using that technology and how great of a fit they are, their use case. You can read like blog posts, for instance, from companies like LinkedIn, but that's really some kind of single point in time, and you won't be able to traverse what has happened since then. And from for instance, throughout a week, it's more a static analysis. And luckily, Wikimedia as a public dashboard on Grafana where you'll be able to see how they are using Kafka, their configurations, their usage. And this is from Wikimedia. This is from a week. I believe that you should be seeing now with a red bar on top. Yeah, okay, great. So what can we see with this dashboard? I won't go into detail, but just if you're new to Kafka, or you probably, it's worth checking how Wikimedia is using it. So they have 9 brokers. That means they have 9 hosts. These 9 hosts handle about 140,000 messages per second, with a read to write ratio about 2 to 1. So for each megabyte published, 2 are read. Well, I'm rounding it up, but but still. And it has about 3,000 partitions. What can we see? What else can we see? Again, this link is available on the speaker notes. We have here a single topic, which is publishing about 100,000 messages per second. And what else? So sorry, I have some notes here. Okay, so this single topic of about 100,000 messages per second, if you go through the configurations, like here, what Grafana makes it available to you, you'll be able to see that that's about 20 megabytes per second written. Each message average 2 kilobytes. This topic has 24 partitions with a replication factor of 3. That means 1 leader and 2 followers. And if we go to the bottom, we see that while handling this much load, Kafka CPU usage is sitting mostly idle, like around 2.5, so 3% idle, 3% usage. And Kafka is a JVM application. And if we look at the heap size, we see that it's set to the limit is set to 2 gigabytes. And that's no sweat for Kafka. But just because Wikimedia is using 2 GB of heap, that doesn't mean that you could be able to also set the 2 GB heap and have low memory. You should have large memory for this caching, which I will cover later on. Okay, so these are the details, these are the metrics. I didn't talk much more. There are much more details here, much more metrics. You'll be able to see afterwards. I won't cover it for the lack of time. Okay, again, if you see the presentation full screen again, okay. So again, as I said, 9 hosts, 2 GB heap, 3% CPU, and the topic handling about 100,000 messages in per second.
Let me just add one more thing here. We discussed this offline last week. So in your application, there's no obligation to keep Kafka CPU utilization this low. It's just a choice that Wikimedia Foundation made. Oftentimes you would have a Kafka cluster and you would max out CPU. It's by no means a requirement to keep it running in the background-ish.
Yeah, that's right, Timo. One of the most CPU-intensive features I've seen is compaction, because it has to go through the logs, and it has also a toll on disk because you're writing a new log file. But yeah, you don't, just because Wikimedia is using at 3%, that doesn't mean that you need to have a 3%. I would just wanted to convey the idea that while handling this much load with 9 hosts, you probably can do it with fewer hosts, and you got to test it out. But just I want to know, on topic 100,000 messages, and you have a lot of headroom on CPU usage. So anyway, just to give an idea. So everything I mentioned until now was something like an introduction to Kafka, and here I'm going to discuss a bit more about the configuration, the properties that I believe, well, in my experience, if not more important, they were at least not understood correctly, or not did do what we expect. Anyway, just a bunch of stuff. So starting from the clients, I've seen people, I've seen the applications tweaking max pull records, expecting it to be able to tweak to control how much data is fetched on each pull.
Let me clarify one thing here. When you speak about clients, you mean the subscribers, right? So the readers.
Consumers and publishers. So consumers and producers.
Oh,
yeah.
Both sides. Okay.
Yeah, this will be on the consumer. This will be on the producer. Yeah. Yeah, I should have probably separated. Okay. I'm going to make it clear what I'm aiming for on what end. Sorry. Yeah, that's a nice catch. So I'm talking about the consumer. Max pull records just controls when you call pull. So give me those records. It controls the amount of messages that single call will return, not the amount of data that is fetched from Kafka. There are other properties for that. Just to bear in mind that, and you probably just do a sanity check if you're using this property with an intention that it was not supposed to be. Again, another thing, and this is common both on producer and consumer, is broker version needs to be higher than client's version. Kafka follows a semantic versioning. I believe this restriction is not required for patch versions, but for minor measure, if you're making your application and you just want to use, for instance, the latest version, you should at least take a look at the broker version to see if they are using a version that is compatible with what you chose. Again, now on the producer side, there's acknowledgement. That means that when you're a producer, you produce a message to the leader and that leader will replicate to the in-sync replica, so ISR. You can ask the producer, okay, when I make this request, I want the leader partition to the leader partition to acknowledge my requests once all the replicas acknowledge that they receive that message. So for instance, if you have a replication factor of 3, the leader partition will only respond to you whenever all 3 partitions, partitions, all of the leader and the 2 followers acknowledge that they've written it and that they've received it. So when you set this property, you may think, okay, if I set it to all, that means that I have a durability guarantee of 3. Well, not really. It depends on your operating system, because Kafka relies on the Kafka default is to let the operating system to flush to disk whenever it pleases. So what can happen? You write a message and all 3 partitions write to disk, but they don't flush. They let operating system, and they acknowledge the message. The broker, okay, everything looks okay. They respond to the producer, and you may think, okay, that's it. If everything goes down, the message has stored. Well, not really, because the message may not have been flushed to disk. And if for any instance, for instance, like the whole data center goes out, you as a power outage, for instance, you may lose those messages. So that may create like an unexpected scenario, that's an unexpected issue, like why did we lose these messages? That may happen. And that's not so common, you can tweak it, but that's just worth to keep in mind. So this made sense. I don't often see this like explanation when tweaking acknowledgements all, and also because in the industry, usually when we see ox all, that means that everything, like we have full consistency or something like that, and full durability, because due to Kafka claiming to be durable. Yeah. So
well, this almost never happens in practice, because there are no power outages. If you have multiple machines that have different UPS modules to keep power on, and yeah, flushes, as in it's written to disk, is such a painful topic by itself that unless you are in the banking sector or unless you build in a black box for an airplane, there's a good chance you don't have to worry about this. Julia?
Yes, I have a question. If this situation happened, that we didn't flush to disk, how could we treat the situation? Because I'm not that we could treat it.
Sorry, can you repeat it?
Yeah, sure. If the situation happened and actually we didn't flush to the disk and we lost messages, and how could we treat the situation?
Well, that mostly depends on how your system is able to replay messages, be able to republish message, because Kafka lost. Okay. Yeah, nothing to do. Again, I can open like if you go to the documentation, which is like a live session. If we go to the application versus flush, you'll see that the drawback of using application level flush setting is that it's less efficient in this usage pattern. And in general, you don't need like to do this, as Dima mentioned. Again, I just want to bear in mind, because if you face this situation, it may be tricky. Okay, why did it happen? How could you have we lose messages? And this may help explain. And again, if you look, I just opened the documentation from Kafka. You can anyway, you can do the same. Just went to search for flush. Okay, so going back to the presentation, yeah. I hope that answered this part. Yeah, so this is one reason that why Kafka may be able to publish, to the end-to-end latency may be lower than your disk latency. That may help explain and why Kafka is so fast despite writing to disk. Okay, so anyway, moving on. Choosing the number of partitions, and this relies on when you're starting a topic. So if you have consumers, you have producers, you need to have a topic in between. And if you have to choose it, to create the topic, you have to choose the number of partitions. But that's kind of tricky. I won't go much into detail and to hashing and go and publish into the same partition and so on. What I wanted to say is like when you're choosing the number of partitions, you're mostly doing a trade-off between latency and throughput. And you should be aware of that. And that tweaking the number of partitions later on might not be completely, well, might not be easy. Again, it depends on your use case. I recommend that you at least read this guide from Confluent. I find it very helpful. And it's worth noting that probably you want more partitions than brokers. So if you want to scale out your Kafka cluster, you can scale out and your partitions, your topic will be available in more brokers. If you have less partitions than brokers, you can add 100 machines, but if you have 10 partitions, you won't be making much use of it. Again, I'm discarding like the leader followers, and again, I'm assuming a replication factor of 1, since Kafka version 2.4.0, Kafka consumers can consume from followers. Yeah, again, so these were for consumers. Moving on to brokers like the hosts. Not much to say, except that you don't, as we've seen from Wikimedia, we don't really need a big heap, but lots of available memory is great for this caching for the operating system. What I mentioned before. So Kafka does not flush, relies on storing the messages on disk, writing like to write to memory, but they can stay for a while on memory. They write the memory to disk, but they can stay a while in memory. And so if you, despite like seeing 2 GB heap, you can like set like, for instance, 20 GB of memory just available, but the operating system will be probably using it actively. Yeah. Again, moving on. CPU and memory, I've not witnessed being at the bottleneck, like running out of memory or the CPU usage going through the roof. Usually, if you enable compaction, you'll see like a bump on CPU usage. But network and probably bandwidth and disk, if you have a topic with 100 GB, you need to have a disk that is at least 100 GB free of space, tend to be like the bottleneck. So this is not every time, but the usual suspects can be network and disk. Again, it depends on your experience, on your application, on your infrastructure, and so on. Here are some tips. So this is mostly related to network and disk. Changing the compression type. So Kafka has a bunch of different compressions, the codecs. You can choose another one, tweak, I don't know, see what fits your shoes. Changing the number of fetchers, so the number of threads that are replicating to other to followers. You can tweak the topic retention, establishing more tightened policies like on disk space or on time, and also enable compaction, and the number of IO threads. Up until recently, if you go through the web and just probably search for Kafka, get started, or tutorials, so on, they advise you to, they start from, okay, you need Zookeeper. from now on, so I believe this is the latest version, 2.8.0, with the Kafka improvement proposal 500. That means that Kafka doesn't need any more Zookeeper. If you're using Kafka right now in production, you probably have Zookeeper still in use, but it's good to have one less dependency on your system, so one less thing to maintain, and it looks good. I'm optimistic with this advance, because it's also easier to bootstrap others to explain how Kafka works. If they have to install multiple tools like Zookeeper and Kafka, that's one more bump on the road. If you just have Kafka, it's easier to bootstrap. Okay, moving on, and this is like miscellaneous. Kafka has exactly once, but you should interpret it for like network retries, and not really if your application tries to send the same message twice, Kafka won't stop you. But okay, so I've seen it in production, and I've not witnessed like no noticeable performance degradation. Again, your mileage may vary. From what I've seen, it worked really well. And so you may want to try it. Again, it's just because Kafka is exactly once, is following the exactly once semantics, that doesn't mean that your whole flow is exactly once. You should be able to, your application also needs to be able to follow this semantic if you want to claim that you're end-to-end exactly once. One thing that is great, besides documentation, is the exposure of metrics. Kafka exposes lots of metrics that you've seen the dashboard, and I know that there are more metrics that that weren't displayed, but the degree of observability that it provides to the user, that is us, is great. You'll be able to, if you're collecting these metrics and if you're making use of them, you'll be able to help narrow down a tricky issue to like a specific point. And there's this very good guide by Datadog. It's just a starter guide. I advise you like start running Kafka and see what it exposes and start working from there. Now, if low latency is your goal, Kafka may not be the right choice, because Confluent made an analysis where Kafka Rabbit is handling fewer messages, 30,000 compared to 200,000, but notice the latency, it is much lower. So if you're aiming for latency, and again, this depends on your use case, your scale, and so on, Kafka may not be the best fit. And you should be aware of that. If latency is your goal, Kafka may not be like the best choice. Still, the maturity, the tooling, the expertise, the community, everything built around Kafka, I believe it can at least take it under consideration, know that it exists and what it provides, and work from there and compare with other tools or other technologies. So yeah, not moving to the demo part. This was on me. I believe if anyone wants to ask questions, can do it now or at the end, right, Dima?
Now is a good time. At the end is a good time.
Okay. Yeah. So I'm just going to wait a bit to see if anyone has a question. Otherwise, I can move it to you. Yeah, I think that's okay.
I think this was great. Thank you.
Yeah, it was great.
yeah. One thing I would add is something that surprised me at some point, which it was a pleasant surprise. Kafka subscribers, the customers, the clients that listen to the messages, they used to have to provide the offset in the early versions of Kafka, and it's quite a limitation because you cannot have stateless subscribers. But apparently I was out of date, and since quite a long time ago, Kafka can handle this part by itself. So I assume it's going to be in the Zookeeper, and since 2.0, it can handle it without Zookeeper. So you can just have the subscriber that keeps subscribing to the data. And once it's down and up or restarted or the new one is added, it would just keep replaying the flow with the exactly one's guarantee, more or less, which I think is fascinating. That's what Kafka should have been doing from day one. It is doing it from version something.
Just to add to that, so each consumer has a client ID and is part of a consumer group. That consumer group is what holds the offsets. And well, there's also rebalance. The Kafka tries to have one consumer per partition. And anyway, those offsets are stored now on, as you said, on a Kafka topic, which is __ Kafka consumer offsets. I've seen it a lot, and so many times that now I can I've memorized it. And another thing, yeah, so you mentioned consumer offsets, and you also have the ability to ask Kafka, okay, give me the offset for this point in time. It may not be the precise offset, but at least will be somewhere around there. It depends on your configurations, because if you have a time index, so you have offset by times, I believe, on the API, you can make use of that. If you don't pass anything, it will just continue from the last committed offset. Yeah.
Yeah, I think it's an important but pretty advanced topic. Kafka has index files, so it builds some internal caches to quickly map offsets to timestamps. So you can actually use it pretty efficiently if your use case is to subscribe to events from certain time point. Yeah, that's what a good replayable message broker should do, and Kafka does do it. Yeah, another important thing here, I think you touched on this. It's probably worth mentioning since we're trying to be more advanced. So when a topic is partitioned and you have subscribers, each partition can only be subscribed to by one subscriber, right?
One consumer.
One consumer.
Yeah. Inside a consumer group. Yeah.
So that's the point is, you mentioned that if you want to potentially be able to scale, you have to choose the number of partitions wisely. Yeah. Why don't we talk about this for a few minutes?
Yeah. So you inside the same partition consumer group, you have a bunch of consumers. Kafka aims considering the same consumer group, you don't have two consumers consuming from the same partition. So what does this mean? If you have 20 partitions, but you have 40 consumers inside the same consumer group, that means that only 20 consumers are actually being used. The rest is like just sitting idle. So and that's a really nice idea, an interesting point. When you're choosing partitions, you need to be mindful about scaling out the number of brokers, but how you scale out the number of consumers. If you plan to have 100 consumers, but you don't have enough partitions, that won't get you anywhere. If you're using the same consumer group. But okay, so you may say, okay, I will just have I don't know, 1,000 partitions and leave it there because I might grow larger than Amazon and Google scale combined. But once you do that, that means that you're preferring throughput over latency. That means that your producer will have to reach out to more brokers to be able to publish those messages. If you have 1,000, the partition spread over 1,000 brokers, if you are a producer and you are like producing, you need to reach out to these 100 brokers, and all the moving parts that are in between. if you have fewer partitions, you need to reach out to fewer brokers. And that means that if two partitions are sitting inside the same broker, that means that you can send both messages to the same broker once, not having to make separate connections. This is also made very clear on the Confluent guide that I linked, but it's worth bearing in mind. And also, if you're not using, if you're not using Kafka version until 2.4.0, that means that you may have 40 followers, but all the consumers are reading from the leader. All the followers are for availability. So if one goes down, all the in-sync replicas, one of them will be the leader. And that means that you have a fault tolerance of n partitions -1. Just one needs to be alive, assuming that all are in-sync replicas. And this also takes a toll on performance, because that means that you're replicating the same messages 40 times.
Well,
as I said,
not necessarily,
ideas.
Right? Each message goes into one partition, so it has to do with replication factor.
Oh, if it has a replication factor of 4, or let's say 40, that means that you publish the message to the partition leader.
Right.
Partition leader, and the partition leader later on will have to replicate to all its followers.
Right. It's just that if you have a replication factor of, let's say, 5, it doesn't really matter whether you have 10 partitions or 100 partitions. You would still, the leader would still write to 5.
Oh, yeah.
Right. So
okay. Yeah, okay. Yeah, I get you.
The latency is not because it has to talk to more machines. The latency is because they're different machines. It has to keep more connections open.
Yeah. Thanks for sending me correcting me. Yeah, that's it. Again, I'm mentioning a lot of what I believe simple ideas, but what I'm describing here, I recognize it is complex, as I mentioned before. Complex, but the ideas are simple. And then we mentioned here a bunch of ideas: consumer groups, partitions, and partitions, the influence on producer side, on consumer side, on the number of brokers, so on. A bunch of ideas.
Timestamps, index files.
Yeah,
I think if you used Kafka for more than a few years, and you certainly did, you get past the Dunning-Kruger curve, and you again think it's simple, but yeah, we are fully aware it's not simple, even though the ideas are remarkably straightforward. All right, thank you. This was awesome. If you give me back the host, I'll share the last few slides.
Yeah. Wait. Yeah,
I am the host now. Yeah, thank you. Thank you, António.
Thank you for having me.
Share screen. This is the guy, right? Yeah. All right. Disclaimer. It is just my style to try to criticize the technology before I admire it. So I'm probably going to sound a bit attacking of Kafka. It does not mean I don't like it. Moreover, in practice, a couple of years ago, I used to not like SQL databases for too many logical reasons. But ultimately, I've converged the idea that even though they have drawbacks, they're still among the best solutions to the data storage and querying problems. So it may well be the case with Kafka. I'm just trying to, my strategy, my style, if you wish, is to keep finding flaws. So let me just move this. Doesn't work. All right. So with this being said, I figured the best way to outline my thought process here would be to try to describe the circumstances under which it is reasonable to look for alternatives to Kafka. So the use cases where Kafka can seemingly work, but is probably not the best solution. And I've grouped these use cases into a few categories. Let's tackle them. The first category is if you have a large-scale notification servers. Effectively, if you have a bunch of different consumers, if you have a bunch of different custom application pieces of logic that need to subscribe to a very non-trivial, not easily defined set of messages. So in practice, Kafka has topics, so you can always subscribe to a topic. But let's say you have 20 bits associated with it, with each message, and you want to be able to subscribe by a bit mask. So if you want to use topics as the only filtering criteria, you would need to have 1,000,000 to the power 20 different topics, which is totally infeasible. So in practice, what would happen in this case is you would have more consumers than you need, more or less, and they would do some client-side filtering. So in order to reduce the load on the Kafka cluster itself, you would have workers that are idle for most of the time, yet have to process most of the messages multiple times. If your problem has to do with this use case, if you sometimes need to subscribe to a small subset of messages, but it is hard to put this filtering criteria into simple topics, you probably may want to build something custom, which may be based on top of Kafka, but it doesn't have to be the case. The second use case, the second realm of problems is when you need to replicate a database. The dreaded standard use case is OLTP to OLAP replication. So the way things usually work in real life is you have some OLTP database, which is online transactions processing, which is what your application server is working with. And then you have some kind of queries, some analytical queries, which may or may not be prod related. So the latency on those queries is the allowed latency, the expected latency is substantially larger than real time. They could be something analytical which runs, let's say, every hour or every 24 hours, or it could just be some update, some features in the machine learning table, which can be done frequently-ish, but latency of a few dozen seconds is fine. So what usually happens in those applications is you have your production cluster that runs production. It has a bunch of databases, and you want to keep a copy of these databases in a different place where you can build your own caches. It's a different set of application servers running here, which is supposed to replay the mutation log, replay all the transactions that happen here in the on the OLTP side. But instead of just blindly updating the database, it's not just real-time database replication. You have some custom logic on the OLAP side. So on the one hand, it's a canonical use case example for Kafka. I believe Kafka was designed to solve exactly this problem within LinkedIn. On the other hand, it quickly becomes high throughput, low latency. And I think another even more important point here is that in this problem, the order of messages begins to matter. I would not talk a lot about vector clocks today, but the idea is that sometimes it's critical for, if you have two transactions, if you have two mutations of your OLTP, sometimes it's important for these two mutations, A then B, to end up on the OLAP side in this A then B order. And you could say, hey, you know what? For every single writer, for every single microservice on the OLTP side, I'll just have its own topic. In which case, that machine just, if it's the same application logic, the same server, the same machine, the same user request that has been handled, that results in transaction A, then transaction B, then you are guaranteed that B comes after A within the Kafka messages flow. Well, yes and no. First of all, within a topic, partitions are not necessarily synchronized, so you would have to use one partition per topic. But let's say you can afford it. Let's say you say, I have a bunch of services, each of them has a bunch of shards, so I'm going to have one topic per each shard of each service. And within each shard of each service, the order is guaranteed. Well, again, yes, within the same user request processing by the same machine. If it goes A after A then B, then on the OLAP side it would have A then B. But then, interestingly enough, if this service talks to another service, so it does A, then talks to some other service, and then gets a response from this other service, and then does B. That request to another service may also produce some mutations in the database, in the state of your system. Maybe you need to authenticate a user, validate the authentication token, check their friends list, make sure they have no restrictions on this user. And if that request from your service X that produces A and B to service Y that produces C, if these are two different machines and they write to two different topics, there's no guarantee these two messages would end up in the right order. So you would indeed get B after A, but you would not get ACB. You can get ABC or even CAB. In which case, your logic on the client side would have to put a lot of work on the client on the receiving end, so that you can handle these CAB or ABC orders. So you could you could stash some data in the local cache and wait until C arrives, maybe a couple messages later, a couple milliseconds later. But it's tons of extra logic. So oftentimes you actually want it to be a singular time, so no vector clocks, no multiple dimensions of offsets, timestamp, indexes, or whatnot. You would like it to be a single stream of updates where a single unique ID, unique index determines everything. That every single offset divides your data flow into before and after, and you can only do it within Kafka if it's a single topic, single partition, which again is not so performant. And the third use case I think that is worth noting specifically is there's a modern trend, modern as in it exists for at least 5 years as of today, that if you're working with tons of data, pushing code to data is preferred to pushing data to code. It's a lot easier to design. Well, it's a lot more effective in terms of CPU usage and network usage and overall performance if you can push your data, push your code, push your processing logic exactly to where the data is. Because in the vast majority of cases, you need to crunch tons of data, maybe terabytes, to produce a small distilled report output, which could be literally kilobytes. So it's just ridiculous that you have to transfer terabytes of data over the network so that your 3 crunching machines can do the crunching job. Even if you write it in assembly, the network would kill you. That's why technologies such as Hadoop, they mostly took off because they've embraced this idea. They said, hey, you know what? We store the data not just in an effective format on disk. Not just we don't just cache this data effectively. We just make sure that whenever you need to run some code that processes this data, we would push this code to the nodes that store the data and run the query in there, run the logic there. So Kafka is I wouldn't say it's a closed system because it's an open source system, but it's pretty hard to imagine the real life application where the author of the code would hack into Kafka to introduce some custom logic at the, let's say, at the point where messages leave the Kafka node and send those messages to the consumer. You could, but it's just a bad idea for so many reasons. You won't test it properly, you would have to catch up with new versions, etc., etc. So I would love to see the design where there's some, I have a slide on this later on. I would love to have the design where there's some way to natively inject some code at that location. And Kafka, to the best of my knowledge, is just not designed for these purposes. It's an advanced use case. I'm fully aware of this. Not necessarily what Kafka was designed for. And again, I have a lot of respect to Kafka for what it does. It's just important to understand that, well, when you're reasoning about whether your use case, whether your application, whether your needs do or do not fit Kafka, if you feel like you would win a lot by being able to run a simple piece of code, a simple code snippet, at where the data emerges or is being sent out, you probably want to use something different. Even Redis has, well, not even Redis. For a while now, Redis has Lua. Redis doesn't have transactions per se. They have multi-operations. But what's more important, Redis has Lua, which allows you to write simple code snippets, simple if-else statements, which pretty much mimic transactions. You could say modify this and that under certain condition, and if it doesn't hold, then do something else instead. If you want to do something like this with Kafka, which to me sounds like a very plausible use case, you just won't be able to. You have to write your own logic at the producer side and/or at the consumer side. Makes sense so far? This was supposed to be a fourth bullet point, but the more I thought about it, the more I realized it's just an example that encompasses all the 3 points above. So imagine your problem, your task, is to build a messenger, large-scale worldwide messenger used by billions of people. It is just so tempting to think of the messenger data store as the large-scale distributed database, which in a way is true. I honestly think that designing the messenger is pretty much designing a large-scale database with custom use cases. So you would say like, hey, if Alice wants to talk to Bob, and Alice is in Europe and Bob is in America, you would have some database shard in Europe and in America, and some channel which replicates data from Europe to America so that messages reach Bob from Alice. Well, you could do it, and on the first glance, it does sound like the use case for Kafka. In practice, look, message delivery is simple. Notifying the user they have the message received, they have the message, well, sending the user a push notification or sending a WebSocket request if they have a browser client. You could just build a special service for that would scale horizontally and send those notifications. But then you need to keep track of when was the user last online, which again sounds like a case for compaction of Kafka. But the volume of this would be tremendous. And if you want to deliver this beacon messages, this, hey, I'm online as of the past 1 minute or so. If you want to deliver this to every single user who has, so if I'm going online, offline, I probably have hundreds of people who speak with me from time to time, and I'm probably in the top 3, 5, 10, or however many fits the screen for a dozen people. So in practice, what should happen in a perfect world is when I go offline, on those 10 screens of my 10 friends who have me in the top 10, maybe not 10, but 3, 4, whatnot, you would want their devices, their phones or browsers, to get the notification that I'm now offline, or that I'm now back online. Again, this sounds like a simple subscription use case, but it's possible to do it with Rabbit in a pretty bad way, but possible. What people usually do is use Erlang here, or build some really custom logic. Kafka would just not handle this, trust me, for exactly this reason. You would need to do a lot of somewhat lightweight custom logic on a huge number of messages. So not the best backend. And the icing on this cake is, if you would like, so when I open this messenger app of myself, I'd like that when I just open it, I'd like the top 10 people to be selected by some machine learning-ish algorithm based on who is online and whom I'm more likely to speak with right now. So maybe based on time of day, or their time zone, or the frequency of messages I've seen from them in other group chats. Again, this sounds like a simple problem. Forget machine learning. This could be a bunch of heuristics with simple hard-coded coefficients. Delivering this data to every single device, or at least having the backend that serves my particular device to collect all this data in real time, is a super hard problem, which to me is a data bus message broker delivery problem, but it's far from what Kafka is good at. So yeah, what I was thinking is, take Telegram as an example messenger. It's just, I don't think it's the best messenger. It's just the easiest to talk about. Had Kafka been the perfect message broker, Telegram would not have its own backend. It would just be a huge Kafka cluster with a bunch of add-ons such as notifications on the backend and iPhone apps on the front end. Maybe in a while, Kafka 10.0 would be an example of an application, of a backend application that can do this job. Today, you could design it in such a way. If you're interviewing for a mid-level or senior position, I could even accept such a design. We can talk about that, and I would say, hey, you seem to know what you're talking about. In practice, I would highly not recommend designing a messenger based on Kafka, specifically because it just happens to incorporate all those weak spots of Kafka. Again, I'm not saying Kafka is weak, it's just not the scope of problems it was designed to solve. So yeah, Kafka is really great at what it does. Let's just keep in mind that there's no magic bullet. There's some fine print to this. On performance. This is actually one of my favorite topics. Favorite as in, to this day, I can't wrap my head around why don't we, as the technological humankind, why don't we strive for linear time? Why do we even have to work with vector clocks? I know if you have to deal with billions and billions of messages per second, and they're mostly not connected to one another, that's okay. You can chart this. But in the vast majority of cases, what we end up having is a stream of messages, a stream of events that is just in the order of 10, 100 mil per second max. And life gets so much easier if they are all linearized, if they all have their unique IDs and the order is respected. And somehow we don't have a solution on this planet that does this linearization for free. So Kafka, if you look at their numbers, it's pretty hard to find official numbers somehow. But if you look at their numbers, for a single topic, single partition, it is north of half a gigabyte per second. So I think I've seen 600 gigs per megs per second, 800 megs per second. So let's say it's slightly under a gig per second. Most messages are short. If you really want to optimize for time linearization, you can afford to keep all messages short. Because if some message is large, you can always first put its contents somewhere else, Cassandra-ish, super quick key value store, and then just publish this ID of this published blob to Kafka. So I can easily imagine a system where the majority of messages are under 100 bytes, let's say under half a kilobyte. But then within this design, somehow this half a gigabyte per second doesn't work. Somehow Kafka can only handle, I think it was like 150k messages per second per partition, per topic per partition, which to me is really low. I just cannot possibly imagine how can it be so low, literally. I mean, Postgres can do more, Redis can do more. Of course, Kafka does a lot to make sure these messages are propagated and stored in multiple places and can be consumed, subscribed to from multiple subscribers, multiple consumer groups, etc., etc. Still, I can't wrap my head around why is it such a low number in terms of sheer messages per second. And yeah, so effectively, my point is, if your goal is to somehow scale this messages per second number above what Kafka can offer, let's say Kafka can do 150k or even 200k messages per second, and you want just 1 million per second, a really low number. On the one hand, you want all Kafka's guarantees, such as consumers, groups, replayability. On the other hand, you would need to write custom code. So if you use Kafka for this problem, for data storage and reliability, which is a good idea, you would need to write custom software that would join topics or partitions and give you the unified linearized stream of data, which you can do again. But then in order to do it, what you would have to deal with is custom code, which might as well use something like Postgres with auto-increment indexes and multiple tables as partitions, and it would give you comparable performance, if not higher performance. And if you use Redis, it's going to be a lot higher. So again, I'm not advocating you rebuild Kafka using Postgres or Redis. I'm just raising the concern that when it comes to linearizing messages, when it comes to making sure the messages flow has a fixed order to it, Kafka is just, not to say a bit too slow. I don't want to throw out numbers here. Just in my experience, Kafka is slow exactly to the point where there's this easy region, there's a super high performance region, and there is this middle ground. And somehow Kafka is barely entering the middle ground. So most real-life problems would need to be somewhere in the middle of this. So Kafka needs to only be 3-5 times faster for it to be considered a really serious solution for database replication or for messaging. And somehow it's not. I understand why Kafka is not there. I understand it's solving different problems. Just as somebody who's working on high performance most of my life, this looks strange to me. Any questions so far? Yeah, I should really make a disclaimer that again, I'm not attacking Kafka. That's just my style of learning more about the product. It is not. I respect Kafka a lot, and it's not impossible that a year from now I would say, hey, it's one of the best things that the humanity has built so far. Or maybe in a few years, I'll be tasked with building something faster, and it would emerge internally or externally. Last but not least, when you have to integrate with Kafka, Kafka is built in Java. Kafka runs on top of JVM. JVM is not too bad. Trust me, it's actually one of the best JIT compilers available out there today. Even garbage collection is not that much of a deal. But Java and serialization, they just don't play well together. So imagine you need to route messages to consumers based on some contents of this message. If it's a JSON or XML, I'm just, oh my god, like seriously, you need to do a lot of parsing, use tons of CPU just to extract one single field to make a decision whether it goes to consumer A or consumer B, or even make it easier to make sure whether this message should or should not be sent to consumer X. Let's say you care about performance and you put binary blobs there, and the logic is as simple as look at the byte at offset 8, and then if it's 1, 2, or 3, look at the byte at offset 15, and then make the decision. Something like this is best to be done at this JIT, just-in-time level integration. And as I said before, Kafka just doesn't really offer this capacity. Redis has Lua, tons of other applications, tons of other products these days. So yeah, to connect the dots, this has to do with pushing code to data. I would like to be able to build a subscriber, build a consumer, where the consumer filtering logic is a small dot class. Let's remain in the Java world. I want this dot class to be dynamically picked up by my Kafka cluster to perform that simple lightweight operations and filter messages that I'm consuming. And it's just, to the best of my knowledge, it's not possible out of the box. So this is something I would really want to use. I can totally see how this would make Kafka a lot more applicable, a lot wider used, and it's not what Kafka is working on, as far as I've heard. So yeah, to recap on this part, again, since part of my job, part of my passion is help people learn how to design better systems, it's a system design meetup. System design oftentimes is about being able to build complex systems by combining the existing simple components in a clever way. And I think Kafka is a really important component in this regard. I think it totally earned its place. I would say that maybe the most common component in software these days would be application servers, which you shard somehow. Then you would certainly have databases and load balancers. Message brokers probably be the fourth on this list. And Kafka is likely the most cited. So if you want to be able to build modern systems, if you want your system to do more than just query processing, if you want it to be able to talk to the user in real time and notify the user, chances are you will need a message broker, and you have to know what Kafka is. Absolutely. If your system is designed to scale horizontally, as in if your constraint or your preference is to not try to build it in a high-performance fashion, but to build it in a shardable fashion. So your backend is, let's say, Python or Node.js, not two high-performance languages, but they're easy, like low entry barrier, easy to find developers, easy to add features, easy to test these days. If you're in this realm, by all means, be no afraid to push JSONs as messages into Kafka and handle the rest later. That's, I think, the healthy approach to designing systems. If your startup takes off, you could rewrite this. If it doesn't take off, congratulations, you have not wasted your time trying to over engineer something. Just keep in mind that this approach has some limitations. As Antonio said, at least think from the day one about your number of topics and partitions and how to configure Kafka. Read up on this. There's no magic bullet. Even if it works pretty well for you for the first 3, 6, 9 months, there are simple mistakes you can avoid and make sure as your product skyrockets exponentially, you can still keep living off your current existing version 1 backend that is Kafka-based and JSON-based. If you do it right, you can live with this for quite some time. If you don't do it right and you suddenly experience hypergrowth, well, you have to rebuild things faster, which is not bad too. Just keep it in mind. I think it's pretty much all I had to say, and we're entering the final stage.
Before questions, if you can go to the previous slide, or
of course.
And I would just like to add my take, if you don't mind. Oh yeah. So I believe Kafka clients, so consumer and producer, are Java, in Java, but the broker is in Scala, I believe. But that doesn't, from what you said, everything stands the same. It's just a minor add-up. Also, Kafka uses Apache Avro for serialization. So just to make it clear, I believe when you're mentioning JSON and XML, you're talking about the application messages and not really the Kafka itself. Also, I believe you mentioned a really interesting take. Kafka, I believe it's dump brokers and smart consumers. And what you mentioned, it would be smart broker, where you would actually push the code to data, but dump consumers, perhaps. So
I want intelligence everywhere.
Which, yeah, I'm just saying where Kafka is focusing. For instance, for rebalances and so on consumer side, that also happens on a consumer and not on the broker. But yeah, I'll have to check that, but I believe that's a procedure. So when you say code level integration, I believe Kafka is not adding that way. As you mentioned, if you want on your system such capability, yeah, Kafka does not seem like the best fit. Yeah, and that was what I wanted to bring up.
Yeah, thanks. So I think smart consumer down publisher is pretty much always the best solution. So there are a lot more use cases for smart consumption than for smart publishing. I just think it's an overstatement. My claim is that the consumers, the complexity, the intelligence, the smartness of Kafka consumers, in my worldview, they are not the power of Kafka. They are the natural consequences of the limitations of its performance, of its single topic, single shard performance. So there are tons of customizable things you can do on the consumer side, which would be unnecessary if it was truly smart, as in if you could write custom code, that if you could push custom predicates as push code to data. I'm not saying it would be the better solution for Kafka itself. It would be harder to use for simple tasks. I just honestly don't think it's that smart.
Yeah. Well, we are on that. I was just saying, considering what I've seen from Kafka, they were to. I don't think they are moving into the direction where you would be able to extend the broker implementation. And perhaps they would be closer to extend the consumer or the client's implementation. That's what the direction I perceive from Kafka, but everything changes, and well, from a year now on, perhaps I'm very wrong, but right now
No, Kafka is an Apache project, and it's a Java project. These guys tend to move slowly. So I think in one year you will be approximately as right as you are today. Yeah, that's why I put clean in quotes here. So clean as in, remember we keep bringing this up on pretty much every second meetup, every other meetup, that sometimes the best interface is not HTTP, REST, JSON, or whatnot. Sometimes the best interface is the API that is partially deployed on the client side. So sometimes you actually want some smartness to be. So if imagine Kafka is your black box, and I know it's wrong direction, but I keep doing this. Imagine Kafka is the black box. You write from here, and you consume from here. So if your design requirement for the black box is that the writers just use standard HTTP, TCP sockets, and the consumers also receive the data in the raw format right away, Kafka may be the best solution. But in my world, again, and I'm not claiming Kafka has to do it, it's just the way I see the world. In my world, if you want to make sure you don't waste in latency, in throughput, in CPU, oftentimes your consumer would contain some part of Kafka in itself, so that the protocol is a lot more high performance, and part of the unpacking logic happens on the server side of the client, of the subscriber, and the same goes to the publisher. For example, publisher has to talk to the leader in the current Kafka design. This logic to track who the leader is could be part of the publisher's logic. Publisher can always know who the leader is, try to publish there. If that node is no longer a leader, the response would be, hey, I'm no longer a leader, try there. And the publisher on the client side of the publisher, on the application level side, would publish to a different location. Right now, if the black box design requirement is for Kafka to be a black box, these optimizations are just not possible. And I think at some point they become essential to make another 5, 10, 25x performance boost, which is just there, and resources are being wasted. Like, CPU cycles matter. We're warming the planet. Let's try to make the best use of every single joule we burn.
I have some questions because I didn't entirely follow your line of thought. So producers do know who is the partition leader. So when they start, they will query, okay, who's the leader? I believe, and they publish to the leader directly.
So, okay, let's consider some real life example. What would be the language in which you build your producer?
The language.
Yeah. So is it like JavaScript or Scala or? What I'm trying to say is that the client code, the application layer of your application, you would not write those if statements. Hey, I would like to query who the leader is first and then talk to this leader. You would call the function that is Kafka.publish.
Okay.
So
okay, now yeah, okay,
yeah,
I get it. When you talked about the producer side, it's like really the Kafka library as well.
Right.
Is that it? Oh, okay, yeah.
So
definitely.
If you are forced to expose this Kafka.publish method as an API call, you're quite constrained. If you can control part of the library as well, you are less constrained. Or you could say, you know what, if you want to publish to Kafka, run this local Kafka daemon, Kafka publishing daemon, which would do the job for you. It would be part of the zookeeper or whatnot. It would keep track of who's the leader, even without you publishing anything. And it would make sure the latency of publishing is minimized. That's not the way most people who use Kafka think, but that's the way I'm forced to think due to the nature of my work. And this is not the direction Kafka is taking, which again is not necessarily bad for Kafka. It's just what I have to point out as an engineer, as an architect in this way, in this regard.
So here in this scenario, you wanted your application to be naive and be able to publish anywhere and let Kafka, like the brokers themselves, be able to figure out where to place that message? Is that it?
Well, it's a question of where do you draw a line, right?
Yeah.
I want the application code to be as naive as possible. I want the part of the Kafka library that is right next to my application code to handle everything. I want the boundary, the demarcation line between Kafka and my code to not be at the API spec, but to not be at the network protocol spec. Send this JSON or this Avro message here, or this gRPC message here. I want it to be on the API spec in the client-side language. So if you have a Java Kafka publisher, I want it to link against the Kafka. Well, I wanted to import a Kafka publisher API, which would expose a single method, publish, which would handle all the intricacies by itself. And I think in this design, you're opening yourself, your headroom, your potential for improvement in performance and latency is a lot higher, because you can make changes not only on your Kafka black box side, but also partially on the client side that talks to Kafka. As long as you respect the API convention, you can just ask your clients to rebuild their binaries so that the optimizations on that client side improve the whole system.
But isn't that what the current implementation is doing? We just expose like a send method, I believe, after configuring. Like you configure the producer. Okay, now you just have to send the messages.
I have to confess I have not sent messages to Kafka from Java in 5 years. But yeah, I'm actually not sure. But if you open the connection to the Kafka, to a single Kafka node, then you're constrained already.
I'm not entirely following.
So imagine Kafka has on the producer side. Imagine there are five machines to talk to. One of them is a leader. I can easily imagine that Kafka's Java library on the publishing side would contain the logic that would reestablish connection to the new leader if the leader if what used to be the leader just died. I'm positive Kafka would do it. I think it's highly likely in my mind that Kafka's Java API would do it. I'm not sure Kafka's Go or Python API would do the same. I think they would need to just send HTTP or TCP or Avro requests to certain endpoint, which is hardwired there. Or am I wrong?
I'm just not quite sure. We can be language agnostic here, right? Because we're just following a spec, right? The library, each library and each language is following a spec.
So what does the spec contain? First go there and figure out who the leader is, then talk to them unless they fail to respond in time or tell you I'm no longer the leader. That's quite some logic to be implemented on the client side. And if the client has to implement this logic, then upgrading this protocol would be a pain. I think we're talking about the same thing. My point is that in the perfect world, this logic is concealed from the user in all languages. Kafka just offers its own API in multiple languages, like what Avro or protocol buffers do. Or Thrift. They would just say, hey, define the protocol schema here, and for 20 plus languages, you have this modules generated for you. I would want it to be the same for Kafka. Define the schema here, run the scripts, and for 20 plus languages, here's how you send these Avro messages to the Kafka cluster you have configured with some INI file somewhere or with some JSON configuration somewhere. Instead, we have to talk to it via network by composing our requests ourselves, which I think is a limiting factor.
So let's say that Kafka has a bunch of libraries on multiple languages, so either Python, you can rely on just using a library on whatever language you use. So I'm not following what would be here in this scenario, what the problem would be. If you just are, as a client of that library, you are just exposed to an init method and a send method, nothing else. Everything happens behind the curtains. I am aware that comes at a cost, a toll on CPU and perhaps memory and increase communication, but as a developer, as a client of that library, I don't have much to worry about. Okay.
That's what I want to see. If Kafka is already there, that's really good. Yeah, the next question would be, is the actual underlying protocol, is it kept backwards compatible for compatibility reasons, or is it being upgraded every single major release? I think you mentioned that the broker version should be greater or equal than the client version. So then, yeah, I think internally, if the protocol was upgraded, there's a handshake originally, and the client-side API sees if it's talking to the broker of the high enough version. Yeah.
I don't know into many details that level of, well, that communication. I also know that, well, you probably can check with on the Kafka documentation that when the versions and to see if there's an increased compatibility, if you can go with a version above the broken versions. Again, it's not something that I've dealt much about. It's just a concern I have, and I wanted to transmit to others. Still, I'm not like the most indicative person to. I would have to read more about to be able to have an engaging discussion.
Let me ask one more thing about Kafka Avro integration. So, to which degree are they coupled?
As a developer, you are not aware that Kafka is using Avro.
Oh, okay. Even if the sorry, go ahead.
You can encode your messages with protobuf or flat buffers, I believe that's the name, whatever you want, and Kafka will encode like their data, the data from the request. So I don't know, some details about the request and your message in the body, and really encode it everything as an Apache, as an Avro message.
I mean, is there, so if my application itself is based on Avro, do I have any advantages over the application that I don't?
I don't think so. Kafka will re-encode your already encoded message. So you don't have much to gain, well, except for the different trade-offs of choosing protocol buffers over Avro. But choosing either one, Kafka, I don't think Kafka will take advantage of it.
It would be really awesome if Kafka's support for Avro would be like more tightly intertwined. So you could maybe provide Kafka with your own Avro schema, then it would JIT compile it, and then you could provide some predicates that access fields of your messages directly. That would be really awesome, I guess. Not coming anytime soon.
Yeah, and it would be awesome if Kafka wouldn't, as you mentioned, want to go to the byte level, if it wouldn't have to decompress the whole message, like not just yours, well, not yours, but the whole message, just to know what fields are there. But that's, I believe, more of a Avro bump on the road than on Kafka itself. But yeah, Kafka has a choice here, chose Avro over several others. But yeah, also, yeah, but Kafka has a bunch of optimization. One really common one is zero copy, if I recall correctly, yeah, and so on, which aims to transfer directly from disk to the network to avoid, but that's to avoid different change context switches.
Yeah, I would need to read up on this. I wonder how is it possible to do zero copy and at the same time re-encode every message into its own Avro packet. I think it would probably put bunches of messages together with a single Avro header.
I believe, so if I recall correctly, once you send a message, again, I will have to check on me on that, but I believe that broker will re-encode the messages and will re-encode in batches, and those and saves it on disk. When you're a consumer, you're reading from this, and the one that the side that decompress that message read from this, that's compressed from Avro, is the consumer. So consumers decompress the message and not the broker.
Right. So if that's the case, that's where this 150K per second comes from, because the smaller the message size, the higher the CPU usage becomes. And then at some point it hits 100%, I think. Yeah.
Yeah. And you also, Kafka, I believe, tends to kind of help with that with a config that's called linger, I believe, which is just, okay, you send a bunch of messages, but you can set like, let me wait 100 milliseconds before that library actually sends those messages. So you can batch them up and send like one big batch instead of small messages. Again, this is a trade-off between throughput and latency.
Yeah, but that's for network zero copy. If you still re-encode every single message.
Okay. Yeah, I'm just saying that Kafka, I believe, made this decision into that direction. But yeah, I believe they are aware of that bottleneck, like the re-encoding. And that, yeah, as you said, and nice bridge that helps convey the idea why 150K would be like, why couldn't we go above that?
Wonderful. Well, if there are no more questions, I think we should call it here. Thanks a lot. This was great.